All right, what's up, guys? Today's lesson starts off chapter 4 for us, okay? And 4.1 is about congruent figures, okay? Everybody knows what congruent means. Remember, we call it being equal. Well, here, not only is it equal, like in measure, but it's also equal in degrees and shape, all right? So congruent figures have the same size and shape. When two figures are congruent, you can slide, flip, or turn one so that it fits exactly on the other side as shown on the right. In this lesson, you will learn how to determine if geometric figures are congruent. And you can determine when two figures are congruent by comparing their corresponding parts, okay? You guys remember corresponding, right? Corresponding, when we talk about corresponding angles, they lie in the same position, okay? Same thing with corresponding parts. All right, so our first definition is congruent polygons, okay? And for our example, it says if polygon ABCD is congruent to polygon EFGH, what are the congruent corresponding parts? Well, let's start off by saying the line segment. So we have line AB is congruent to line EF. Line BC is congruent to line FG. Line CD is congruent to GH. And DA is congruent to HE. All right, so that is the line segments. Now we can start talking about the angles that are congruent. Well, angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. All right. Now these are the corresponding, the congruent corresponding points of these two polygons. All right. Part 1 says finding congruent parts. If HIJK is congruent to LMNO, what are the congruent corresponding parts? All right. Well, let's look at the sides first. All right. Well, first we have side HI. Okay. And HI is congruent to LM in the other polygon. HI and LM. All right. And then we have J is congruent to MN. And then JK is congruent to NO. And last but not least, KH is congruent to OL. All right, and now we have to list the corresponding angles that are congruent, corresponding angles that are congruent. All right, so we have H and L. I and M. N and J. And last but not least, K and O. And then here it says if triangle WYS is congruent to MKV, what are the congruent parts? Well, we have angle W is congruent to angle M. Angle Y is congruent to angle K. And angle S is congruent to angle V. All right, that is the angles. Now let's do the sides. WY is congruent to MK. YS is congruent to KV. And SW is congruent to VM. Those are the 6 congruent corresponding parts. If the two picture triangles are congruent, then what is the measure of angle D? Okay, so we want to find this angle right here, all right? Well, if these angles are congruent, then the corresponding angles are congruent, given B and E are both 30. So if C is 75, then F should be 75 as well, okay? Then we could use the triangle sum theorem, which states that all three angles in a triangle have a sum of 180 degrees, okay? 30 plus 75 is 105, and we need to subtract 105 from both sides. And so the angle D has a measure of 75 degrees. And part B says, suppose that W, Y, S, and M, K, V are congruent. If angle W is 62 and Y is 35, what is V? Okay, so remember, if angles are congruent, then if triangles are congruent, then the angles are also congruent. So M is 75. Oh, no, excuse me. M is 62. K is 35, and we don't know V. So we can use the triangle sum theorem, 62 plus 35 plus the measure of angle V equal to 180. 62 plus 35 is 97 plus the measure of angle V. Now we just have to subtract 97 from both sides, and the measure of angle V is 83. All right, so part 3 asks us, are these triangles congruent? Justify your answer. And then it asks us, how do you know if the two triangles are congruent? Okay, well, let's start looking at what's labeled and what's given to us. So AB is congruent to ED. BC is congruent to DC. AC is congruent to EC. And angle A is congruent to angle E. Angle B is congruent to angle D. And angle BCA is congruent to angle DCE because they are vertical angles, and vertical angles are congruent. Now, here we have all three sides are congruent, and all three angles are congruent, okay? Now, this is what we call the definition of congruent triangles. If they have three equal sides and three equal angles to the corresponding angles, then the angles are congruent. Then the triangle is congruent. All right, theorem 4.1 is the third angles theorem, which states if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So if angle A is congruent to angle D and angle B is congruent to angle E, then angle C is congruent to angle F. So look at part 4. It asks us, prove that these triangles are congruent. So we need to look at what's given. Okay, so what's given is LM, line segment LM, is congruent to LO, and angle M is congruent to angle O. Line MN is congruent to ON, and angle MLN is congruent to angle OLN. All right, and so here we just we want to prove that LMN, triangle LMN is congruent to triangle LON. All right, so let's start with the line segments. LM is congruent to LO, and MN is congruent to ON. All right, and that is given. Okay, that is given to us. Now, since these two angles, since these two pairs of line segments are congruent, and the way that the triangle is, the two triangles is written, well, we know that two of the line segments are congruent. But look at the third side of each triangle. Well, in triangle LMN, the line that we're missing is LN. And in triangle LON, the line that we're missing is LN as well, okay? Now, of course, LN is congruent to LN, and this is by the reflective property of congruency, okay? So, of course, the line segment equals each other, but if we're looking at two different triangles, then they're not the same side, all right? So now let's look at the angles, okay? So we have angles M and O are congruent, and angle MLN and angle OLN are congruent, okay? So if these two pairs of angles are congruent, then the third angle, which is angle MNL, and angle ONL are congruent by the third angle theorem. Okay? And then since all three angles are congruent and all three sides are congruent, we can say that triangle LMN is congruent to triangle LON by the definition of congruent triangles.